Good morning. My name is Prasoon Divan. I'm going to talk about programming. When we think of programming, we think of data structures, algorithms that manipulate them. If you're good, program documentation, and if you're in trouble, seeking help. This is the traditional programming process. Today, for more and more problems, we instead throw statistics at data to get our results. The overall goal of this project is to blur the distinction between these two approaches to programming. Specifically, we want to treat all these artifacts we create around programming, both the code and natural language, treat them as data on which we throw statistics to create inferences and recommendations that help traditional programmers meet their requirements. So, what kind of help can and should we provide? Here's one approach. Given a program that's giving trouble, we generate a patch that corrects the program. This approach is easy to define. We create a concrete fix that guarantees correctness. Unfortunately, the halting problem says that we cannot implement such an approach. And it's not clear we want to always give the exact solution, especially in an educational context. Here's an alternative approach. What is inferred is not the exact patch, but an abstract hint, ideally in natural language. And this hint is to be interpreted and validated by the programmer. And what it leads to is not necessarily a correct program, but a modified program that eventually becomes correct. So if you're going to generate a natural language hint, it's useful to mine not only the exact code, but all natural language artifacts created around it, including forum interaction. For hints, we need probabilistic algorithms, and machine learning is one example of such an algorithm. So like many of the projects in this department, this one too is heavily centered around ML. So our helpful programming environment works with a machine learning model, which makes it problem independent. Given a programmer difficulty, it generates hopefully a useful recommendation. And because now the historical data has changed, given the same difficulty later, it can give a different result later. In this project, we are focusing on student programmers because we want to build a system that's actually used, and we are in a university setting. And in an assignment, all students work on the same problem, so there's more similarity in the programs that are mined, which should yield better results. So we have a nice symmetry here. We have machine learning, we have student learning, and more the system is used for student learning, the better the machine learning, which should result in better student learning. So there's the possibility of a symbiotic virtual cycle. And that's the good news. The bad news is that machine learning can fail and lead students to unfruitful paths, especially if they're novice programmers. So another research question is how to solve this problem. Our solution is to bring instructors into the picture. They're the ones who are responsible for verification of the hints generated by the automatic system. And the students are responsible mainly for interpretation of the verified hints. So we now have two kinds of humans in the ML loop. The students who are getting into trouble, and the instructors who are working with the programming environment to get them out of trouble. And this makes it exciting because we can now do two kinds of user studies on the students and the instructors.
So far, we've seen the vision. Here's a concrete example. Here, I've asked ChatGPT to correct my solution to the factorial problem. It comes back with first an English explanation of the problem, the missing base condition, and then it gives me a version of my code that has this fix. And like I said earlier, we may or may not want this solution to be given to the students. The factorial problem was chosen not because it's expected to pose difficulties, but because of its familiarity. These are two areas in which we expect hints to be particularly useful. Distributed and parallel computing, because they're inherently complex tasks, and data science, because it's typically carried out by non programmers. We are building on and trying to improve existing ML technology. And towards this end, we've collected many years of um, interaction logs of students programming in different programming environments. And if you want to know more about this kind of work, do send me a mail. Thank you.